All right, guys, we're going to go over a calorimetry problem. My goodness, that's a weird word to say. I know there's going to be some questions about this as you guys are probably going through the PowerPoint. So hopefully this will help clear some of that up. All right, so when 25 milliliters of water containing HCl at 25 degrees Celsius is added to 25 milliliters of water containing sodium hydroxide at 25 degrees Celsius in a calorimeter, however you want to say it, a reaction occurs making the total mass 50 grams. So calculate the enthalpy change in kilojoules during the reaction if the highest temperature observed was 32 degrees Celsius. So I know this problem sounds tricky because there's a ton of different numbers in it. There's some givens that it doesn't really clearly say in the problem, so hopefully this will help clear it up. So when you're going through this example problem, first let's look at the equation. So this is going to be the same thing as the change in enthalpy. So again, the capital H stands for enthalpy. Again, this little triangle delta, that means the change in enthalpy, okay? So that's going to equal the mass times the specific heat times the change in temperature, okay? So it's asking us to calculate the enthalpy change. So the enthalpy change is delta H, okay? So that we already know that's going to be our unknown. C, again, which is the specific heat, it doesn't tell you exactly in the problem, but your specific heat is always going to be something that is given to you. So the specific heat, specifically of water, because this is what we're talking about, is water in the problem, is 4.18 joules per gram Celsius, okay? So that's probably where a lot of confusion came from, is like, where on earth is this number coming from? So again, with these kinds of problems, I'm always going to give you the specific heat, okay? So the mass, this also sounds confusing because in the problem it's talking about milliliters and all this stuff, but then it says it comes to a total of 50 grams. So this is just kind of extra wording because this is something that I want you guys to be kind of practicing anyway and going through a problem, figuring out what's important and what is not. So the total mass, okay, again, we're just looking at this, making the total mass 50 grams. So our mass is going to be 50 grams. And our change in temperature, okay, so that's going to be the final minus the initial, okay? So the highest temperature, this is going to be the final temperature, is 32 degrees Celsius. But when it started out, it was 25 degrees Celsius, okay? So your change in temperature is going to be 32.0 minus 25.0, which is 7.0 degrees Celsius, okay? So for plugging all of this into this problem, so delta H, which is your change in enthalpy, equals your mass, which is 50 grams, times your specific heat, which again is always going to be given to you. Your specific heat of water is 4.18 joules, and then times your change in temperature, which is 7.0 degrees Celsius. Okay, so if you multiply all of this out, our change in enthalpy is going to be negative 1463, which is, if we were looking at our sig figs, is going to be negative 1500 joules. So if you calculated this out originally and this was a much smaller number, that is because, again, it's asking for it in kilojoules. Again, going back to your problem, calculate the enthalpy change in kilojoules. So if you calculated all of this out, you would have gotten joules originally. Okay, so that's why the number looks a little bit different than how you may have calculated it out. Oh, I forgot the minus sign up here also. So this is always going to be a negative number if these are always positive, okay? So if all of these multiplied out are a positive number, then make sure that you're adding the negative. If this final number comes out to be negative, then a negative times a negative is a positive anyway, so then this number would be positive.